Alright, Chapter 4 is on chemical bonding. Um, Introduction to chemical bonds. There's three major types. Ionic compounds are strong, they transfer electrons. Covalent shares electrons, sharing is caring. They are relatively strong. And metallic bonds are very strong, which is basically localized electrons that are C of positive and negative charges. We'll get to that later. So what you have here is a strong covalent bond between atoms. It's not between molecules, but between atoms. Here you have intermolecular forces between molecules, which are weak for covalent molecules. That's why chlorine, hydrogen, fluorine are all methane are all weak gases because they're weak intermolecular bonds. Type of intermolecular bonds, we have van der Waals, which are also called London dispersion forces, which basically have temporary dipole moments between atoms. You have permanent dipole. That's something like water. Well, and then a specific type of dipole bond is called hydrogen bonds, and that's water, ammonia, and hydrogen fluoride. Alright, ionic bonding. Ionic bonding is the transfer of electrons. You can see here that the sodium ion electron from the outer shell transfers over to chlorine, giving chlorine 8 in the outer shell, which makes it a +1 sodium and a -1 chlorine. And that plus and negative causes an interaction between the atoms to make the ionic bond. It's an electrovalent bond, meaning that they have a positive negative charge. The metal and non-metal go to noble gas configuration by losing electrons from the metals and gaining electrons from the non-metals, and it forms a positive negative attraction. They form in a regular pattern, so they are crystals. It's a very strong bond. Alright, dot and cross diagrams you can see here. We talked about this, that the electron transfers, so you have a +1 for sodium and a -1 for chlorine. Notice the difference in the number of electrons from 11 to 10, from 17 to 18. This shows all the electrons. All you need to do is make sure you show the outer electrons. So the metal should basically be empty, and use square brackets to show the charge in the upper right hand corner. So for example, you would see sodium chloride like this. Notice sodium is empty, chlorine is full with the extra electron from sodium. Alright, so if you have calcium chloride, basically you need the formula CaCl2, so you need 2 chlorines because calcium gives off 2 electrons. Only one can go to chlorine, so you need 2 of them to make CaCl2. So the chlorines look identical, each having 1 extra electron, and calcium's empty. Here you have magnesium oxide. You can see here oxygen can give or take 2 electrons. Magnesium can give 2 electrons. So you would just have a +2 charge and a -2 charge, making a strong magnesium oxide bond. The higher the charge, the bigger the stronger the bond. Here's the calcium chloride again. You can see calcium loses 2 electrons. You need 2 of them, 1 for each chlorine atom. Here and here. Alright, homework question is to draw a dot and cross diagram for the following ionic compounds. Use only the outer electron shell. So again, the metal should be empty with the transfer electrons to the non-metal. Make sure you remember your brackets and your charges. Alright, covalent bond. So covalent bond is like a Venn diagram. They share electrons. So you can see here, chlorine is a sharing of electrons between each other. So it still has 8 electrons around it, making it stable, but they're sharing that pair of electrons. The line represents the structural formula, represents a bond. So that bond here is the sharing of 2 electrons. One line represents 2 electrons. So, drawing the molecules, you use a dot and a cross, or an X. The outer electrons are drawn to emphasize the number of bonding pairs and lone pairs. So you always have some bonded pairs and some lone pairs in your compound. And most molecules follow the octet rule, which means they can have 8 electrons around the nucleus. Here you have hydrogen. Hydrogen only has 1 electron each, so they are going to share, make a bond. There they are sharing, and that's the structural formula with that bond representing 2 electrons, 1 pair. Methane. Carbon has 4 electrons in the outer shell. That means there's 4 bonding sites. That's why the formula for methane is CH4. 1 hydrogen for each of your lone electrons. You can see here the bond, 4 bonds, 4 lines representing the structural formula for CH4. Water. Oxygen has 2 lone electrons, so that means there's 2 bonding sites. So that's why the formula is H2O. It's not specific on where the H's go, but in the structural formula you want to make sure you have a bent structure showing a bond between H and O and 2 lone pairs around oxygen. Ammonia. Nitrogen has 7 electrons in the outer 5 electrons in the outer shell. That means there are 3 bonding sites, and that's why 3 hydrogens will bond to nitrogen to make ammonia. And the structural formula you can see here, 1 lone pair with 3 bonded of hydrogen. Hydrogen chloride. Chlorine has 7 outer electrons. That means it only needs 1 to make 8. That's why there's only 1 bonding site, and you have HCl. Alright, things that do not follow the octet rule is boron and sulfur and some other noble gases like xenon. Boron can fit 6, and sulfur can actually hold 12. So here you see boron has 3 bonding sites. That's why you can only hold 6. So you have 3 things around boron. In this case, boron trifluoride, and you have a trigonal planar BF3. Sulfur has 6 outer electrons. So for the exception for sulfur is that you can have 6 bonding sites. Fluorine has 7 outer electrons, so it only needs 1 to make a bond. So for each sulfur electron, will form a bond with fluorine, making sulfur hexafluoride. Alright, use your dot cross diagrams following covalent bonded molecules. Make sure you only use the outer electron shell. You got tetrachloromethane, CHCCl4, and you got phosphorus trichloride, and you got bromine, Br2. Multiple bonds. Alright, so oxygen can have 6 outer electrons. That means it can only have 12. That means extra sharing has to occur. Extra sharing means multiple bonds. So you can see here, if you count all the bonds around oxygen, there's 8, and around oxygen on the right side is 8, forming 4 electrons. Each pair makes a bond. That's why it's a double bond oxygen. Carbon dioxide, CO2. Carbon has 4 outer electrons, so it needs 4 bonding sites. CO2 is only 2 of them, so that means extra electrons have to move in to get around carbon and around oxygen. So you can see here there's 4 here, 4 here around carbon. That's an 8, making 2 double bonds, which is 2 bonding sites. Another 2 double bonds makes 2 more bonding sites, a total of 4. Always can have 4 bonding sites around carbon. Alright, ethene. Ethene is C2H4. So the best thing is to have hydrogens bond to each of your carbons. That leaves only 4 carbons to bond. So those 4 have to actually make a double bond to make ethene, because you need 8 electrons around carbon. So you get 4 here, 6, 8. So the 4 electrons make 2 double bond, holding 4 electrons. Nitrogen. If you look at nitrogen, there's 5 electrons, total of 10. So there's 3 bonding sites, only 1 atom of nitrogen each, so that means you need a triple bond. Each of these 3 electrons will pair up with the outer ones, and you would make 6 electrons around, plus 2 in the outer, 8 around each nitrogen. 6 electrons means a triple bond. Each pair represents a bond. There's 1, 2, 3. Alright, coordinate bonding. That basically means you are sharing electrons from an empty atom. So to make ammonia, nitrogen has already 8 electrons. It's fine. It's ammonia. To make ammonium chloride, hydrogen has no electrons. So we can actually jump in and share the 2 electrons of nitrogen to make ammonium NH4+. It's plus because of the hydrogen missing that 1 electron. Making molecules. Making molecules is basically attraction between electrons. So here we have aluminum chloride. You can see aluminum has 6 electrons around it. So it's actually a pretty positive charged atom, because aluminum has a lot of protons. There's negative charge parts of chlorine here. You have all these electrons here. So there's going to be attraction between the protons and electrons between other chlorine and aluminums. Same concept here with this aluminum missing a pair, and chlorine has all these electrons, all these positive charge from aluminum. They will make a crystal and make a ionic compound, and it continues millions and millions of times to make a cube or a crystal. Alright, so using dot and cross diagrams show the formation of coordinate bonds between BF3 and ammonia, NH3. The compound will be F3BNH3. And show that phosphine and a hydrogen atom will form a polyatomic ion of NH4+. Okay?